All right, guys, let's talk about ionic compounds, how we figure out what particular ionic compound pair of elements is going to form. Let's start off with sodium chloride. Let's analyze this situation. Here's sodium. What does sodium want to do? Sodium wants to lose one electron. Why? Because if it loses this one electron, it's going to have a full outer shell. How can we tell this? Well, you can look at the periodic table. You can just look at a picture of the atom, whatever you want. But we can see that if it loses this one electron, the shell right below it will be the outer shell. That shell is already full, so it'll have a full outer shell. And if it loses one electron, it's going to have one more proton than electron, so it's going to have a +1 charge. And so sodium's going to lose one electron. It's going to become sodium +1 or Na +1. It's going to form the sodium ion. What about chlorine? Well, chlorine has a total of 7 electrons in its outer shell. To get a full outer shell, to become happy, it needs to get one more electron. If it gets one more electron, it's going to have one more electron than proton, than the number of protons, so the charge will be -1. So chlorine is going to gain one electron and become Cl -1. And that's kind of a good situation. So you have the sodium has a +1 charge, the chlorine has a -1 charge, and if you have one of each, they balance each other out to create a neutral ionic compound, or which is NaCl. By the way, this is obviously table salt. The sodium is +1, the chlorine is -1. That cancels each other out, and you end up with the neutral ionic compound, the neutral molecule, NaCl. Let's take a look at sodium phosphide. Now, sodium is still sodium. Sodium wants to lose one electron to become Na +1, just like before. Sodium always wants to lose one electron. Let's take a look at a picture of phosphorus. This is phosphorus. It has 5 electrons in the outer shell. All right. It wants to gain 3 more electrons. Why? Because if it gains 3 more electrons, it'll have 8 electrons in the outer shell. That'll be a full outer shell. Now, if it gains 3 electrons, it's going to have 3 more electrons than protons, and that means its overall charge will be -3. And so phosphorus wants to gain 3 electrons and becomes phosphorus P -3. And so how do you balance it out? Well, if you have three sodiums and 1 phosphorus, that balances out. So the 3 sodiums create a +3, the 1 phosphorus creates a -3, and so then the formula for sodium phosphide is Na3P. Now here's what's important. If you have just 1 Na and 1 phosphorus, that doesn't work. Because then the Na is +1, the P is -3. The whole thing doesn't come out to a neutral molecule. So it has to be Na3P. It can't be anything else. You only have one. Sodium phosphide is Na3P. It's not Na2P. It's not NAP. It's Na3P, and that's the only thing it can ever be. So if somebody talks about sodium phosphide, this number does not change. This subscript, that's always a 3. That can't be a 2. It can't be a 4. It can't be anything other than a 3. Let's take a look at sodium sulfide. All right, so sodium still wants to lose 1 electron. As always, sodium wants to lose that 1 electron so it can become Na +1. That's its goal. Here's sulfur. What do we see? It has 6 electrons in its outer shell. To get to 8, it needs to gain 2 more electrons. If it does that, its charge will be -2. So sulfur wants to gain 2 electrons to become S-2. And to make that work, you need 2 sodiums. That's where this 2 comes from, this Na2, and 1 sulfur. Now, what if you had just 1 sodium and 1 sulfur? Well, that's not going to work. Sulfur wants to be S-2. Sodium wants to be Na +1. A +1 and 1 +1 and a -2 would lead to an overall charge of -1. That's not going to work. The overall charge has to be 0. So the only way for this to work, the only way for sodium sulfide to exist, is if you have 2 sodiums for every 1 sulfur, creating this thing Na2S. All right, let's take a look at calcium chloride. Here's calcium. Calcium has 2 electrons in its outer shell. In order for it to become happy, to have a full outer shell, it has to lose these 2 electrons. If it loses those 2 electrons, it has 2 more protons than electrons, and so its charge will be +2. Calcium wants to lose 2 electrons, it becomes Ca +2, and just as always, chlorine wants to gain 1 electron to become Cl -1. So how do we make that work? Well, if this is a +2 and this is a -1, you're going to need to have 2 chlorines for every 1 calcium. And that's how we express it like this, CaCl2. The 2 means there's 2 chlorines for every 1 calcium. Now these numbers can't be changed. This has to be a 2. You can't have CaCl5 or just CaCl by itself. It has to be CaCl2. Let's say you just had CaCl, why wouldn't that work? The Ca would be +2, the Cl would be -1. That would not create a neutral atom. The total number of positive charge and the total positive charge has to be equal to the total negative charge. It has to cancel out, so the whole thing is neutral. All right, calcium sulfide. Calcium wants to lose 2 electrons, just as before. Sulfur wants to gain 2 electrons, just like before. If calcium loses the 2 electrons, that means it's going to have 2 more protons than electrons. It becomes Ca plus 2. If sulfur gains 2 electrons, it becomes S minus 2. Then, so let's see, how can we balance these out? How can we make these work? Well, this is actually kind of nice, right? The Ca is plus 2. That would be canceled out by the S being -2. So you just need 1 of each. You need 1 Ca and 1 S. And that gets you a nice neutral compound, CaS. And that's the only thing it can be. It can't be CaS2 or Ca2S or Ca5S or anything else like that. All right, now let's do a big one. Calcium phosphide. Calcium phosphide. What are we going to do with this? Calcium wants to lose 2 electrons to become Ca plus 2. Just like before. That's what it always wants to do. Phosphorus, as always, wants to gain 3 electrons to become P minus 3. Well, now this is going to be hard to figure out because let's say you have 1 of each. Let's say you have 1 calcium, 1 phosphorus. That doesn't balance out, right? Because then there would be plus 2 and a minus 3. The overall charge would be -1. So you could try to have, say, 2 calciums, but then that would be a plus 4, and then this would still be a -3, and then you'd have 1 too many positives. So how do we figure this out? Well, you just gotta figure it out. You just keep increasing the numbers and trying out different things. If you want to have something that you think about in your heart, think about, common denominators with fractions. That's a nice thing to get your mind right. But you just have to try out different things until something works. And what ends up working, I'll tell you what ends up working. If you have 3 of these, it becomes a +6. And if you have 2 of these, it becomes a -6. And that's what ends up working. You get Ca3P2. That's calcium phosphide, and that's the only thing that's calcium phosphide. If you make this CaP with no subscripts, it doesn't work because then it's too negative. If you try to make it Ca2P, then it's too positive. The only correct subscripts you can put, the only thing that is calcium phosphide is Ca3P2. Nothing else is that. So if you change these numbers, it's wrong. It has to be these numbers. And what we're doing here is trying to figure out what these correct subscripts are to create this ionic compound.